Hello, everyone, and welcome back to the last session of Techignite, a speaker series organized by NTU College of Engineering. My name is Luke, your MC for today, and we are honored to have Mr. Daniel Ang, Senior Director of Civil Aviation Authority of Singapore, or commonly known as CAAS. He will be sharing with us about the plans and progress that CAAS is making towards decarbonizing the airport industry. As you listen, don't forget to take note, think strategically, and wonder how you, yes, you, can fit in this picture. I'm sure there is opportunities here. Now, may I have the honor to welcome Mr. Daniel Ang to begin sharing about CAAS work. Mr. Daniel Ang, please. Mr. Ang, I think you are muted.
Hi, can you hear me now?
Yes, I hear it.
Yeah, so thank you to the team and to Luke for the introduction and to the NTU team for the invitation to speak at this webinar. So today's sharing will really talk about what are our plans at CES to look at how we can make Singapore a more sustainable air hub. So the slides will just provide you with some context in terms of some of our plans, and I would certainly like to hear some of your thoughts as well, and then I would be quite happy to entertain any questions in the Q&A later. So the first question is really, what is climate change about, and what does it mean for Singapore? So I think many of you will be well aware, certainly in the last few years, the issue of climate change has become more salient and more obvious to all. I think certainly before that, there could be people who are still denying that climate change is happening, but certainly in the last few years, we have seen really the real impact of climate change. And what does it mean for the world? That also means that actually countries, governments, companies are also facing greater pressure to want to do something because it is an existential threat. If nothing is done, things will just get worse and it will really affect lives, society, businesses around the world. So what does it mean if we talk about aviation? So aviation is generally a very small sector where you talk about climate change emissions. We account for about 2%. The challenge is, and I think all of you from the engineering school will be well aware, it is not a sector that's very easy to decarbonize. If you think about how flight happens, actually you need a lot of energy to provide the thrust and the lift to have an airplane fly in the air. And that energy use is actually exponential if you talk about flying long distances, because you need to burn fuel to carry fuel. So the challenge for aviation is that actually it's not easy for us to decarbonize. If you talk about technology, many of you will be well aware that aircraft technology does take many decades to evolve. Many of the aircraft that we see today, whether at Changi Airport or across the world, many of them could have been in operation for 20, 30 years. So that is a long replacement cycle. There are new concepts that are being thought about, things like hydrogen aircraft, blended wings, electric aircraft, but we are really talking about technology that will take decades. We're really looking at perhaps at the earliest, something in the 2050 timeline. Second option for decarbonization is alternative fuels. So we talk about using potentially fuels produced from other sources, typically waste materials, what we call sustainable aviation fuel. The technology is available, but it is very, very limited. And as we will share later, it is also very, very expensive, typically 3 to 5 times more expensive than normal carbon fuel today. The third option, of course, is to just buy your way out of the problem. Just invest in offsets to offset and reduce the carbon footprint of the sector. But it is also shouldn't be the preferred option. I think we all recognize that all sectors have a responsibility to decarbonize and to make best effort to decarbonize. And we really shouldn't be looking to buy ourselves out of the problem unless really it is absolutely necessary after all other viable options have been exhausted. So that's where aviation is when we talk about decarbonization. In Singapore, just to provide some context, when we look at the emissions, it is dominated really by international emissions. When we talk about domestic emissions, this is really the tied to two sources of emissions: energy use at Changi Airport, and also the use of fuels, carbon fuels by vehicles that you see running around the airport. So if you look at the pie chart, about 85% of domestic emissions of Changi Airport is driven by electricity. So electricity to power the baggage systems, to keep the lights on, to provide the air conditioning, all the essential equipment, 85% of that is due to electricity. And in order for us to reduce the footprint, we will really need to look at other sources of renewable energy, because the carbon intensity of the electricity will then matter. And then you see on the pie chart, slightly over or slightly under 15% will be other sources of fuels. A large part is actually diesel. So all these vehicles that you see on the apron, when you look at the apron at Changi, those that are pushing the tractors, baggage tractors, other equipment like catering trucks, all of this are currently powered. Most of them are being powered by diesel. There are some electric versions that are already being used, but we are looking at how we can extend that. Then the next part is about international emissions. And as you can see, international emissions basically covers all the emissions that are tied to the operations of Singapore-based carriers. And that actually is the largest part. So we are talking about Singapore Airlines, we are talking about Jetstar Asia, we're talking about Scoot, all the carriers that are based in Singapore. And the challenge for us is that if you talk about ambition, we are not in an area where ambition in aviation climate change action is very strong. I mean, in Europe, in North America, certainly you see a lot of airlines making very bold statements about what they want to do. In our part of the world, actually, it's the minority that are now focused. Typically, we're talking about the Northeast Asian carriers, for example, in Japan, where they perhaps have ambitions that are more closely aligned with North America and Europe. So there's a competitive concern then for us. If we are too ambitious in our goals, we make air travel too expensive, then the challenge is then how do we ensure that Singapore remains competitive as an air hub? So that's something that we are quite concerned and we are quite conscious of as we lay out our plans. And I think the overall message for us as a small island state, and Singapore, at the end of the day, you must remember, is an island, is that aviation is very, very important to us in more ways than one. I think as a society, as an economy, and as a country, we do depend on aviation. So many of you would have traveled, hopefully, since the COVID pandemic is over. And that joy of travel, I think, does create a lot of social benefits. It's essential for things like mental well-being. Many of you may have families or friends or acquaintances overseas. Singapore is a very open society, and many people do travel to visit friends and relatives overseas, or have friends and relatives travel to Singapore to visit them. Logistics, air cargo, the things that you buy online, whether it's on Amazon, Taobao, or whatever, these are shipped into Singapore, many of them by air. Essential goods, everything that you see in FairPrice, in the chiller, most of them are brought in by air. Your fresh fruits and vegetables, COVID vaccines, pharmaceutical products, many of these are brought in by air. And then as we see right now, if you go downtown, you see more tourists. Again, these substantially about 90% of our tourists enter Singapore by air. So aviation does provide a significant contribution to Singapore's economy, about 5% of GDP, and it supports a lot of jobs, a lot of sectors. So the challenge for us is really, how do we make aviation more sustainable? I think many of you may be aware there are certain parts of the world where the response to climate change action in aviation is to not fly. or to reduce flying. There's this thing called flight shaming in certain parts of Europe where activists make people feel very bad about flying, and they're suggesting, you take other forms of transport, rail, busing, maybe even ferries. A lot of these options don't exist in Singapore. Geography, if you look at geography, Southeast Asia, we are covered mostly by water. So aviation is really the most viable means of transport. So for us to continue to have aviation play an important role in our economy, not just in Singapore, but also in Southeast Asia, we will have to see how to make aviation more sustainable so that people can continue to fly, but fly responsibly. So things are moving. The assurance that we give to all of you is that the aviation sector is taking steps. We are taking steps to try to reduce our carbon footprint, and this cuts across the whole world. I mean, countries that you see with each COP meeting, people are raising the commitments that they make. In Singapore, I think last year we also announced at the national level, we'll commit to net zero by 2050. Companies are also doing more to look at providing more sustainable goods and services, and that includes airlines as well. And I think all of you also play an important role in shaping how companies respond. If you are demanding for more sustainable products, if you go and to, for example, a restaurant or to a shop and you ask for no plastics, I mean, people will respond to that demand. Likewise, in air travel, if you're looking for, and you make clear that you're looking for more sustainable air travel products, the airlines will respond to that as well. So this is what the aviation sector has set for itself. These are our goals that we've established just late last year, that the aviation sector collectively is committed to net zero emissions by 2050. Net zero means net zero, not carbon neutral, but net zero. So if you look at the chart on the lower right corner, what you see are three. Well, the total chart you see is under the BAU or business as usual curve, you'll find that carbon emissions could double by 2050. We don't do anything, aviations continue to grow, it could double from about 1,000 million tons of carbon emissions to about 2,000 million. And the four different layers showed how the sector intends to reduce its carbon footprint. The blue layer is about technology. And as you can see, it is backdated. You don't see much effort around or much progress around technology in the next 10, 20 years, simply because a lot of the aircraft that are going to fly in the next 10, 20 years are already in the air or are being produced based on known technology. Nothing, you may have one or two models come up, but nothing fantastic or revolutionary is going to emerge in the next 10 to 20 years. If you talk about blended wings, electric aircraft, hydrogen aircraft, you're looking at in the 20 to 40 window. That's why you see that blue bar starting to get a bit thicker as we move. And the expectation is technological improvements could result in about a 22% reduction of the total carbon emissions that needs to be reduced. And then the orange bar is about operations and infrastructure. This is about really looking at every part of the operation, trying to really squeeze out efficiency and to reduce carbon emissions. And the good thing about aviation is there are many, many flights happening everywhere in the world. So if a process could be found to be made more efficient and replicated, then we can have through scale, the ability to reduce our emissions. That's why you see in the orange bar, about 10%, but the work has already started looking at air traffic management, looking at various processes of the air, as well as on ground, reducing the use of carbon fuels, using electric tractors, for example. These are things that you can do immediately. In the green, it's really about sustainable aviation fuels, replacing the fuels that we use right now, which are largely carbon-based, with fuels that are produced sustainably using different kinds of waste product, even to the extent of just using hydrogen and renewable energy. And you can see 60% of the reductions will come from sustainable aviation fuel. So that's really the game changer for us. Finally, the gray layer, that's what we call market-based measures, which is really about offsets. So as we mentioned, offset is part of the solution, but as you can see from how the layers are displayed, it is seen as the residual solution. So what the sector intends to do is to maximize the potential around technology, to take whatever action we can do around operations and infrastructure, to invest in sustainable aviation fuels, even though they are more expensive. Then finally, for that residual 7%, where we think no further action or no further in-sector measure is possible, then we'll rely on carbon offsets. So that's how the sector has laid out the ambition over the next decades until 2050. So what is Singapore's role? And this is an important part that I think all of us should be aware, and all of us have a role to play. So CAAS, which is the lead agency for aviation in Singapore, we're responsible for various parts of aviation. We are air navigation service provider. We also oversee, regulate key aviation stakeholders such as Singapore Airlines, Changi Airport Group, and we are also responsible for designing and developing the aviation sector in Singapore. So we recognize that sustainability must become a way of life for the aviation sector. It must be part of how we think, we breathe, and how we develop our business decisions in the next 2-3 decades. So we did convene an international advisory panel last year. Some of you may have read it in the news, who provided us with 15 key recommendations. These are shown on the right-hand side of the slide. At the end of the presentation, you will see a link, and the full report is actually available on our website if you're keen to read it. So with 15 recommendations around what we consider to be the 3 key pillars: airport, airline, and ATM, air traffic management, we are using this as the basis for us to further develop what we call the Sustainable Air Hub Blueprint. So this is something that we are working on right now. And the thinking is to develop and to flesh out in greater detail what these 15 recommendations mean for Singapore. What are the things that we need to do? What are the potential gains in terms of carbon emissions reduction that we can derive from these recommendations? And really in a very practical and pragmatic manner, which is what Singapore is famous for, and to start the hard work of implementing these measures. So I'll talk briefly about what are the recommendations. And again, we can have a deeper discussion in Q&A if there's any specific topics that interest you, because I recognize this is an engineering school. So some of these solutions could be quite interesting to some of the students and the researchers in NTU. So on airport side, we are looking at 6 key ways to reduce carbon emissions. Firstly, like I said, it's about energy. A large part, 85% of the emissions are driven by electricity use. So the fastest way to reduce our emissions is either to reduce the absolute amount of energy used or to make the energy we use cleaner. So we are looking at doing both. So a lot of it will be around making our buildings more energy efficient. Many of you may not be aware as you travel through Changi that some of the buildings are very, very old. So for example, Terminal 1 was first built in 1981. So the skeleton, the infrastructure is a 40-year-old building. So we have to do a lot to make that building more energy efficient. So there are a lot of things that we need to do around replacement of chiller systems, looking at smart systems to track energy use, looking at how we can simulate airport processes and to really squeeze out whatever efficiency that we can gain. The second part is about renewable energy. We are quite interested in looking at how we can import renewable energy. I think this will be linked with the national plans in Singapore to get renewable energy from the rest of the world, whether it's in Southeast Asia, and further afield in Australia, even though I think in the case of Australia, the company that was pushing that project is facing some difficulties right now. But we remain hopeful because that is quite key for us to reduce the energy carbon intensity of our energy. The second part is also around deploying solar panels. And that's the part that we are quite keen to try to innovate. Because for solar panels, it is a very straightforward, at least putting on the rooftops. Those are very straightforward. But the larger pieces of areas of land at the airport is actually on the airfield. So, I mean, if you are on the aircraft and you taxi out, you see there are actually many empty patches of grass. It's not there for aesthetic reasons. The grass, I mean, these patches exist for safety reasons. You need a certain separation for the safe movement of aircraft around the airfield, but it creates a lot of empty pieces of land that potentially we are looking, can we put solar panels there? But it is not a straightforward process of just putting solar panels there. These are active areas where aircraft are moving, so there are safety considerations. Glare considerations, you don't want flashy objects on the airfield that could distract pilots as they land. There could be other considerations. Large pieces of metal on the airfield could, for example, interfere with transmission or certain signals. So there has to be very detailed technical studies that we have to do to understand where are places that where are the sites at the airfield where we can safely and cost effectively place differently designed solar panels, because you cannot use a panel that's currently deployed on the ceiling of a factory, for example, and place it on the airfield. You also need to meet certain requirements around fungibility. For example, again, I'm going to very technical areas. The logic here and the requirement for aircraft safety and airport safety is that anything in these areas where an aircraft could encounter, the objects must be what we call fragile. It should not create any kind of obstacle to the aircraft. If an aircraft rolls over it, that object must immediately collapse and not provide any kind of resistance. So, I mean, as engineers, you understand the logic of that. That is to preserve the safety of the aircraft. So whatever solar panels we put on the airfield, even if it's cost effective, it also has to be technically made of these materials. So there's a lot of engineering technical studies that will go into this. Then finally, we're looking at also electrifying our vehicles, like as with the rest of Singapore, looking at using other sources of clean energy, whether it's electricity, hydrogen, or even renewable diesel. Then we talk about sustainable aviation fuel. So what is sustainable aviation fuel, or more commonly known as SAF? Not the Army, but SAF, sustainable aviation fuel. Typically, SAF, from a chemical basis, it is identical to jet fuel. It is just produced differently. So typically, what we use is feedstocks such as used cooking oil, animal fats, vegetable oils. Those are the more traditional feedstock that's being used, and through various forms of, again, chemical engineering processes, you convert these products, waste products, into something that is similar in composition to jet fuel, and that can then be burned in the engines of aircraft, no different from carbon-based jet fuels today. So a lot of production right now are actually using things like animal fats and used cooking oil. That's the main feedstock. But the industry is also looking at other forms of feedstock, where it is biomass, wood chips, agricultural residues, whether you talk about municipal solid waste, the waste products, garbage, literally. And then longer term, we're also looking at using hydrogen as a feedstock to make acid SAF. So you realize that the key challenge for this is, I think the technical element is available. The challenge is that actually you're using energy and using more process to try to convert something into something different. That results in a lot of cost. So currently, production is quite limited, but it is more expensive. So currently, if you look at the chart at the side, you see typically SAF is 3 to 5 times more expensive. And typically, if you look at the average cost of a flight, the largest cost component is actually jet fuel. We're talking about 30 to 40% of the cost of mounting a flight is jet fuel. So it's very expensive to use something that is 3 times more expensive, that is already the most expensive item on your bill. And production is also very limited in the small single-digit percentages. And if you look at the graph, actually it shows that most of the production sites, not surprisingly, is currently now in Europe and North America. Simply because in these regions, consumers, passengers are asking for these products. Governments have put in place policies for these products to be used, and therefore production is actually happening in those areas. What I also want to share is that Singapore this year will also have a SAF plant. There's a company called Neste that it's actually a Finnish oil company, traditionally a oil refiner, but they have transited their business to renewable fuels. So this year they'll start production in Singapore. 1 million tons of SAF is the capacity, and that would actually make Singapore the largest producer of sustainable aviation fuel in the world. So that's, I think, a very important point that we want to make, that even though SAF is a costly product, it also creates a lot of opportunities. It means that Singapore, which we all know has no resources, no such thing as oil wells. We don't have oil wells underneath our island. We import all our carbon fuels. But because of this technology, and because we're in a region where there's a lot of waste product, especially used cooking oil, we are well placed to produce SAF, to take part in this new green economy transition. Now we actually can claim proudly that Singapore is the top producer of SAF in the world. And that really says to the opportunities that may exist as part of this transition. So what does it mean? So every country is looking at this issue. Like I said, in Europe and the US, the policies are perhaps a bit more aggressive. In the European Union, they're looking at what we call a SAF mandate, which is that each airport must blend a certain amount of SAF in their fuel supply. So the example I give is actually SAF is a bit like new water. It can be safely blended into with normal carbon fuel. But because it's more expensive, you have to create incentives for airlines or airports to use them. In Europe, the incentive is regulation. So it's a carrot, not a carrot, it's a stick approach. So everyone must buy SAF and put it into your hydrant. So starting from 2030, it's about 5%, going up to about 63% in 2050, which means that in those timelines, out of every 100, say, molecules of jet fuel from these airports, a certain percentage must be molecules produced through SAF or must be green aviation fuels. On the US side, they're looking at credits. They are offering credits to encourage companies and airlines to use SAF by reducing the cost difference. So both models exist. And here in Singapore, we're also looking at what does it mean for us to also start our own regulation and policy around SAF as well. And we have already made a start. Last year, we started a trial with Singapore Airlines, Temasek, Changi Airport Group, ExxonMobil, and Neste to actually uplift SAF at Changi. So we actually pumped in sustainable aviation fuels into the fuel hydrant at Changi. This was blended with normal carbon-based fuels and also uplifted into aircraft. And it's completely safe. And this was happening over a few months last year, and there was absolutely no incident. It is just like new water, something that goes straight into the hydrant and no one notices the difference. So it shows that at least on a technical basis, SAF can be deployed at Changi. The challenge is a commercial problem. It is 3 times more expensive. So there was also a second commercial element of this trial, where we used the offsets generated by this SAF, and we tried to sell these to corporates, companies, shippers, passengers to offset their travel. So these are the plans around the airline sector. So we're really looking at how we can look at creating more SAF supply in the region, expanding the potential sources of feedstock. For companies who are prepared to pay more for air travel or for cargo services, we want them to come together and perhaps work with us to build demand for SAF and supply this to Changi. And then tied to that is also the commercial element. How can we look at monetizing the offsets created by the use of SAF? So the last part is about air traffic management. Like I said, this is really an area where every cent counts. We have multiple hundreds, thousands of flights happening every day. Many of them follow the same process. So if we could just eke out any efficiency from each process, we'll be able to quickly scale up and create more opportunities for carbon reductions in aviation. This is an area where it does get a bit more technical in terms of some of the potential innovations and projects that we're looking at. But a lot of it is around providing more predictability, providing better information, providing more certainty, such that the most optimal flight profile could be operated for each flight. And with that, we can then reduce the carbon footprint of each flight. The challenge, of course, is that there are a lot of unknown elements. Weather is one. For a typical international flight, you will have to pass through airspace managed by many countries. So there's also an issue of coordination to make sure everyone is following the same process and has the same situational picture to be able to provide the airline, the pilot, the ability to fly the most optimal flight profile. So these are some of the ideas that I'm working at: performance-based navigation, optimized gate-to-gate trajectory or trajectory-based operations. It is quite detailed, but basically the idea here is really providing good information, up-to-date, timely information, up to minute, in fact, so that we can actively design the flight profile at the individual flight level. So for each flight, knowing what are the likely weather events, what are the likely congestion routes, what are the likely situations that could emerge for that flight, and to give this information to all parties, whether it is the air navigation service provider along the entire flight profile, the pilot, the airline, so that they can make the best decisions and design the most optimal flight path for that flight, for that day, at that time of hour, given the weather operational situation of that day. So that's the idea. But it takes a lot of coordination. It takes a lot of new systems to provide that timely information, to provide the ability to predict, and also for shared decision making. So the final slide really talks about some of the international partnerships that we are also embarking. We are an international air hub, so a lot of our work has to happen in the international arena with partners. So we already have different kinds of partnerships and arrangements with many partners, such as the United States, the United Kingdom, Japan, New Zealand, Australia, as well as close to home, our ASEAN neighbors, to look at how we can work together on sustainable aviation. And this is really about building common mindshare to help to work together, and also because a lot of the work here is fairly nascent, to cross fertilize and to exchange ideas, because all of us are approaching the same problem, but with very different solutions to our local context. So the final part here is really about what you can do about flying more sustainably. And I think this is something that perhaps I would like to leave some thoughts for you to think about. I'm sure many of you travel, and many of you have gone on trips around the region. And I'm also very sure many of you don't do anything to offset your travel. So this is something that I just want to share. Actually, today, if you're flying with many airlines, including Singapore Airlines and Scoot, you can already buy carbon offsets. You can already buy carbon offsets to reduce the carbon footprint of the flight. Currently, it is an add-on option. It is not a compulsory payment, so most people don't pay. But if you look at the actual cost, actually it comes up to very little. You're not talking about large amounts. In this case, I think if you look at the chart for a flight to Tokyo from Singapore to Narita, it's about $11 to offset your carbon footprint each way. $11 is maybe, I guess, 1.5 bubble teas. Or if you go to Tokyo, $11 might buy you a decent set lunch. So that in context is what it means to offset your travel. If you are doing CAAS, it's probably somewhat in the same region. A 1% CAAS plan to Japan potentially could also result in that kind of cost. That's the ballpark. But I think many of us, when we travel, we never think about this. But if you look at the actual value of this offset, $10, $11, in the context of your entire travel budget to, say, in this case, Japan, actually it's a very, very small amount. That's even less than 1% of what you need to pay. But I think very often as travelers, when we look at tickets, when we look at travel planning, the one part that we really want to economize on is actually air ticket. We'll go for the cheapest air ticket, and then we choose to spend the rest of the budget on activities, experiences, food at the destination. But what does that signal to the airline? It signals to the airline that actually passengers are only interested in price. They're not interested in flying sustainably. So as long as passengers don't pay this $11, it is very, very hard for the airlines to decide that it has to provide a more sustainable product because passengers are not paying for it. And so that's, I think, a bit of a chicken and egg problem. It's very hard for airlines to price this in. If, for example, in this case, SIA priced in the $22 as part of the ticket, I'm sure many of you will walk away and choose another airline, right? But then if a passenger chooses not to pay this $22 and then continues to complain that air travel is not sustainable, then what is the airline supposed to do? Right? Someone has to pay this cost, and it has to come out from somewhere. So this is really a part that I think it is important for us to think about. As I mentioned earlier, there are different responses to how aviation should become more sustainable. In Europe, the answer is stop flying. Take the bus, take the train, take the ferry. I think in Singapore, the response has to be very different. We still need to fly, we still need to travel, we still need to get out of our island once in a while. Then the question is, how do we make our air travel more responsible, more sustainable? And it is important that when we make these decisions, when we buy these tickets, we recognize that embedded in the price of the ticket is a green aviation element. In time to come, the air travel could become more expensive. As with inflation, as you can see, some of the things such as SAF is going to be more costly. But the response of the consumer then is very, very important. If consumers respond by not buying the ticket, by turning away, going to another airline that offers a cheaper fare but at a higher carbon footprint, then what you're doing is telling the airlines that green aviation is not sustainable. Not sustainable in the sense that no one wants to buy this product, and an airline that tries to differentiate itself by being more sustainable is not going to succeed. And that is not the message that we want to convey to the airline sector and to the rest of the aviation sector, because we all need to do our part to make aviation more sustainable. We all need to fly more responsibly. And flying responsibly does mean that potentially you need to pay more. And that is something that we need to recognize. Just as right now, if you are going to a restaurant and you're paying for something that's more sustainably grown, it is more costly. You go to shops and you choose green label products, it could be more expensive. Likewise, for air travel, we need to recognize that we need to be prepared to be more responsible in our flight choices. So finally, this is the QR code. If you're more interested in reading the IAP report, it is available online on our website. You can scan this QR code to download a copy. And then that's really the summary of the presentation. I'm quite happy to take any questions.
And thank you, Mr. Ang, for the thoughtful sharing about CAAS initiatives towards sustainability. And it's a really debatable topic because there's no easy answer. And I'm sure our audience have many burning questions after listening. So we would like to bring your attention to our QR code at the bottom of the screen. You may scan the code and it will direct you to the slido.com where you may input the hashtag Techignite to post your questions. And for our next segment, I'd like to invite Nanyang Assistant Professor Feng from NTU School of Mechanical and Aerospace Engineering, who will be joining Mr. Daniel Ang for the Q&A session. And the questions will be directed towards either Mr. Ang, Mr. Daniel Ang, or Prof. Feng, or both. And if either speaker have further points and further inputs, please feel free to add in. So there is a first question from the floor. This is directed towards Mr. Daniel. And yeah, the first question is that how COVID-19 has put setbacks to our progress towards sustainability?
Okay, I think the short answer, of course, I mean, many of you will be well aware that for the last 2-3 years, the aviation sector was decimated. I mean, we were closing down at least 2 terminals at Changi Airport. Airlines were not flying. At one point, we only had about 2% of our traffic at Changi Airport. And through this period, actually, what has happened is many companies were in survival mode. And many of them actually were drawing down on their reserves. For those who are perhaps savvy investors or who have known that in SIA, they have issued convertible bonds, they were going out to their shareholders to borrow money. So the pandemic is coming to the end and we are seeing strong return of air travel. But a lot of the good news that you see, the profitability that you see is really to just replenish what many airlines or even the airport operators has lost in the last 2 years. But we are also well aware that the sector that emerges must be a more sustainable one, which is why even though the pandemic was raging, we were already starting to develop these plans. We also, I think at the international level, has committed to that net zero by 2050 target. So the aviation sector is fully committed. But I think what we need also to be is that confidence from passengers and consumers that the aviation sector is on the right path. So it goes down to choices that you make around travel, around being willing to perhaps choose airlines or airports that provide more sustainable solutions, potentially at a higher cost, but that is a signal that is important to provide to those that are trying to move ahead and to make their products and their services more sustainable.
Thank you, Mr. Ang, for the answer. And for our next question, I believe is directed towards Prof. Ang. So NTU has a Rolls-Royce lab, which is a technology company focusing on engines. And the person who asked this question is he's not entirely sure if Rolls-Royce research lab is relevant to aerospace. Could you elaborate more about this? And how NTU, as well as how NTU is contributing to the research space in the aviation sustainability area?
Oh, thank you so much for the questions. First of all, I'm not from the Rolls-Royce corporate lab, so I may not be able to answer that question very well. But I'm able to share with you the kind of research that I'm aware of that Rolls-Royce is working on. Specifically, they are actually an engine maker. So they are actually looking towards electrification of the aircraft, looking at the next generation eVTOLs, as well as electrifying the engines. Recently, we had a talk where we invited speakers to actually talk to our students through our NTU Aerospace Society. And we invited the Rolls-Royce, one of the directors, to come down to share with us. And through that presentation, he also mentioned about sustainable aviation fuels, which Mr. Daniel have actually mentioned just now, that Rolls-Royce is actually transforming their engines towards that portion. They also, in that talk, we also invited Airbus, Boeing down, and they themselves are also developing new aircraft that's actually towards sustainable aviation fuel. So all the companies out there, engine manufacturers, aircraft manufacturers, OEMs, they are all aligned towards the goal of sustainability. So I think to answer the next question of the whether what NTU is actually doing when it comes to aviation sustainability. So in university, we are actually very focused in the next generation technology. We're actually pushing the boundaries. We are actually looking towards things like fuel cell. We're looking towards electrification. We are looking towards AI. CAAS also have a collaboration with us when it comes to Air Traffic Management Research Institute, which Mr. Daniel has shared a lot. So in that institute, we talk a lot about how do you optimize the flight path, how do you actually manage the airspace for the most sustainable means. Within NTU, we also have the civil engineering as well as the building side of the building context, which I think Daniel shared about in terms of airport sustainability. So we do have technologies when it comes to controls of air conditioning and mechanical ventilation systems. For instance, when you go to the airport, you will feel, hey, it's very cold, there's a lot of air conditioning being used. How can we make it more efficient? Do we have new technologies when it comes to this? The lightings, as well as the aesthetics in general, solar panels, all these things, I think that's covered within the university. So many opportunities there, and I can't name all of them. And if you're interested, feel free to reach out to us, and then we will be happy to actually share about this. Yeah. May I just ask a question to Mr. Daniel? I think this is a good opportunity to check with him. So Daniel, thank you so much. There's one thing that always comes to mind. It's the food versus fuel debate that we have when it comes to sustainable aviation fuel. I think this is something that probably no one has an answer. At some point in time, do you foresee us having to sacrifice food to actually produce fuel for certain air travel? And as a result, our food prices may increase. As a result, airline prices may increase in a way. So I don't know. I mean, this is an open question. Nobody has an answer, but I just wanted to see if there's some thoughts from you about this.
Yes, thank you. I think that's a very important question. The current approach that the aviation sector is taking is that we will only consider waste products for the use of feedstock as for the production of SAF. So waste products that I mentioned, things like used cooking oil, so cooking oil that has been used, but of course you have to collect them and then recycle them into SAF. Agricultural residues, so residues that cannot be purposed for food. It could be, stocks, plant stocks, or after harvesting, you have derived the food or the edible elements, whatever remains. Sometimes it's sent for composting. Now it can be used as feedstock. Wood chips, so if you're making furniture, paper products, the leftover residues, sawdust, wood chips, that can be considered. What I can assure everyone is that there is a very strict criteria that the industry uses to assess feedstock. We must be fully convinced that the feedstock used does not, for example, replace or remove from food supply. It does not result in any kind of impact or pollution to water, to land. It should not result in additional deforestation, for example. So the values that we use to calculate the carbon intensity of these feedstock takes into account all these uses. So there are certainly feedstock that, because of the impact on land, the impact on food supply, becomes very, very unattractive and in fact non-viable. And therefore the industry will not use them. So that's how we approach this issue.
Thank you very much. I think this is a very worthwhile journey to look into. Look, pass back to you.
Yeah, and thank you for the answers and the input from the both speakers. And on this note, may I just add that add a question from myself, which I was thinking, because how much is SAF contributing to the progress towards sustainability? As in, how is it through saving the emission of CO2, or is it through which process? Like, how much does SAF actually contribute to our progress?
Okay, so this is where I think we do have technical experts that help us with the calculations. As an example, SAF a SAF produced from feedstocks such as used cooking oil, for example, could potentially be up to 80% less carbon intensive than carbon jet fuel. So which means for every molecule that you replace, a SAF molecule produced from, in this case, used cooking oil with a molecule that's from literally an oil well, a carbon-based fuel, you can reduce your carbon intensity by 80%. This value will vary depending on the feedstock, the technology being used. So in the long term, you would hear this idea called power to liquids, where we are looking at using hydrogen and renewable energy. And in those cases, the carbon intensity could be as much as 100% reduction, depending on the technology being used and the kind of renewable energy. Because a key problem for even feedstock production is that you need to use a lot of energy, and energy is not always green. So if you are using a lot of dirty energy, then your carbon intensity will naturally be higher. Whereas if you use green hydrogen and green energy to produce jet fuel, technically you could be even zero. Technically, but in most cases there would be some residual carbon intensity. But in those cases, that's where the industry is moving towards, looking at green hydrogen and green energy.
I understand. So through the streamlined production of SAF, yeah, that's how we are going to reduce the production of CO2 into the atmosphere. And
oh, sorry, no. You will still produce the same amount of carbon, because when you burn a molecule, the molecule is no different. So you burn a jet molecule and you burn a SAF molecule, you still produce the same amount of carbon.
Okay.
It is just that because we're using waste products compared to jet fuel, because if you embed the carbon intensity of fossil fuel, we are able to achieve those carbon reductions. But the actual burning will be no different. You'll still burn, you'll still be carbon dioxide produced. They don't disappear because it's a SAF. It's chemically identical.
So it's more of a cyclical economy.
It's a life cycle. On a life cycle basis, it's actually less carbon intensive.
I understand. So there's another question from the floor, and this is towards Prof. Ang. So how further can we optimize fluid mechanics or engine efficiency of airplanes? Because the airline industry has existed for a long time, and so presumably research into efficiency has reached its peak. Does it mean it's time for us to pivot to a different technology entirely in the future soon, such as a hydrogen fuel, etc.?
Yeah, thank you so very much for the question. I think this is a very engineering related question that we cover in class. I think the question relates to fluid mechanics. How can fluid mechanics comes into play? So I think Mr. Daniel actually showed in the earlier slide, in the first few slides, about technological advancements in the engineering context. He showed a figure of the blended wing by Airbus. Fluid mechanics still comes into play very prominently when it comes to reducing of drag reduction. So drag reduction is still a common topic. In fact, it's a topic that's actually been widely researched, still being widely researched, although it's a very traditional topic now, but it's still continuously being looked into towards new technologies, towards new methods, because there's a lot of ways to optimize it. There's a lot of design space when it comes to this. When you change the geometry of the aircraft, how does it affect your drag? How does it affect your performance when it comes to movements, when it comes to other things like lift, this and that? So fluid mechanics still comes into play. But that itself is not sufficient to bring about the grand picture of the 2050, the ICAO, the objective of the net zero carbon. So we need many components, many areas to come into play. Hydrogen is one area, decarbonization of airports, as well as air traffic management. All this has to come to play as one complete picture to bring about the whole grand vision. So fluid mechanics, to answer the question, fluid mechanics may not be the main contributor, but it can play a role when it comes to reducing carbon. Yes.
I understand. Thank you, Prof. Ang, for the answer. And as always, we have a practical question on this topic. So what are the current opportunities for 2023 engineering graduates in sustainability roles? And do we need any additional certification to work in sustainability projects in Singapore? I suppose this question is towards Mr. Daniel Ang.
Okay, I would say that there's probably no certification needed at the moment. I think as what I could tell from the conversations, a lot of the solutions are based on known engineering disciplines. I mean, it's not rocket science, so to speak, right? I mean, if you're looking at and designing solar panels that can collapse on the runway, you're looking at materials, you're looking at different kinds of elements. So it's really about skills and interests. And actually, when you look at a lot of the jobs that you see in the aviation sector, we don't really have a job title that says sustainability. Because the idea here is that it has to be a way of life. It has to be a way of thinking about businesses. So, for example, we are looking at installing more chargers. We are looking at implementing more electric vehicles, energy storage. This may require some disciplines around energy management and electrical engineering, but the job title is not going to say sustainability. It might be something around more like airfield, airside vehicle, deployment. So be open and to look at the different opportunities, the different job descriptions. Because I think very often people expect to go into a sustainability office to do these projects. They think that only a sustainability office in the company will do sustainability projects. That is actually not the case in the aviation sector. It is really across the board. For example, if you're in Singapore Airlines and you're looking at reducing the footprint or the weight of your cabin products, actually it's in cabin services. They'll design the food products, they design, lighter weight catering equipment. Their job title that has nothing about sustainability, but the work contributes towards sustainable aviation. Likewise, in the Changi Airport Group, in SATS, the work actually what we do expect and anticipate is that more and more, every job will have an element around sustainability because it is so core to aviation.
Right. Maybe I would like to echo what Mr. Daniel actually said. There's no specific role that actually is on. In NTU, we do not offer a degree, a certificate on sustainability, but we offer engineering degrees. All these degrees, be it mechanical engineering, be it aerospace engineering, be it electrical engineering, chemical engineering, material science engineering, all these plays a different role and as well they contribute towards sustainability. For instance, mechanical, you can come into place in terms of the better fluid mechanics, better aircraft, aerospace engineering, you have better air traffic management, material science, new materials that can make the aircraft more lightweight, contributing to a cabin, like what Daniel actually said earlier. Chemical, actually new sustainable aviation fuels, the process flow. Electrical, for instance, can make it electrical aircraft, electrification of the aircraft. So every single field contributes. So there is no such thing as a sustainability degree, but I'm quite sure that you will be able to find means to actually contribute to this with whatever degree or whatever training you get.
Thank you for the input from both speakers. And as a last question that has a rather debatable nature. So so from the government side, I think Mr. Ang can answer this. What is the government most inclined towards implementing in terms of the most promising option for the aviation industry? Is it solar? Is it hydrogen, SAF, or something else? And also from the technical side of view, I think Professor Ng can answer this. So which option is the most viable? I think, yeah, it's an open question.
Maybe I'll take a step first. I think it goes back to my first comment, which is that in order to keep an aircraft in the air, you actually need a lot of energy, and you need an energy source that is very dense. That's why jet fuel works so well. It's dense, it's compact, and you can burn it. You have a lot of energy coming out from that. I know there's a lot of talk about hydrogen. Hydrogen is air, so it has a lot of volume, so it's not easy to compress hydrogen into an energy dense form and still be used safely in an aircraft. Likewise, electricity, there are concepts around electric aircraft, but batteries are heavy. So again, it's very, very hard to imagine. I think in most cases, we're really looking at maybe a 10-seater, 20-seater max for electric aircraft. If you can't carry 100, 200 passengers on batteries alone, the amount of batteries you need from an engineering point of view makes it impossible to lift the aircraft. That's why sustainable aviation fuel is currently the main game changer. Chemically, it's identical to jet fuel. It is a drop-in fuel, which means it can be used in any kind of engine that currently already accepts carbon jet fuel. It is energy dense, so it is easy to carry. Yeah, so that is really where we are focusing on sustainable aviation fuel. Hydrogen, electricity, those are novel options, but the applications in the near future will be very, very limited.
Does Professor Ang got any input into this?
Yeah, I think Mr. Daniel actually covered most of the things that we want to talk about. But I must highlight in terms of the on the government side. I mean, I'm not. Okay, I'm from ITU, but not from the government. I think that is from the government. So I think in general, in Singapore's context, when it comes to renewable, not just on aviation, but in general, let's say, for instance, Singapore wants to do a sustainable future, sustainability, we look into many alternatives. So there is a diversification in terms of energy resource. So we look into it solar, we look into it hydrogen, we look into methane, we look towards many areas. For instance, there has been calls for grants into looking towards new energy source to power your homes, to power many things. So research is ongoing, and in university, that's what we do. We push the boundaries and we look into new solutions. Who knows, maybe one day sustainable aviation fuel may not be the best. We have something even better than sustainable aviation fuel. So hobby is for you to actually investigate and come out with a solution. Yeah.
That is a very interesting answer and input from both speakers. And with that, I believe we have come to the end of the session due to time constraints. And on behalf of NTU students, I would like to extend heartfelt gratitude for Mr. Daniel Ang and Prof. Ang Bing Feng for setting time aside to share with us your exciting and invaluable work. And with that, yeah, we have to conclude the session, and as well as the Techignite Speaker Series of 2023. Do look out for the recorded videos, which will be uploaded to COE, College of Engineering YouTube's channel. Thank you, everyone, and wish everyone a happy Chinese New Year, and see you next year.